For me to record it, you'd have to make me a co-host as well, but that's up to you.
Well, we're recording it now, and
Perfect.
I will I'll link you up with the file after we're finished.
Fantastic. Okay, great.
So David is a professor in the Department of Medicine at McMaster University, and previously a professor of psychiatry at Bangor and Cardiff Universities in the UK. He studied medicine at University College Dublin, Ireland, and at Cambridge University, and is a former secretary of the British Association of Psychopharmacology. He has written over 230 peer-reviewed articles and 24 books, including The Antidepressant Era, Let Them Eat Prozac, Mania, Armageddon, and most recently, Children of the Cure and Shipwreck of the Singular from Samizdat Press. His main areas of research are the adverse effects of treatment, clinical trials in psychopharmacology, the history of psychopharmacology, and the impact of trials and psychotropic drugs on our culture. David, thank you so much for taking the time to chat with us today.
Aaron, thank you very much for asking me. Now, let's just see if I can share screen. Now, you cannot start share screen while other participant is sharing. So
that's okay. I just unshared, so I think you're on the clear.
So, right, let's see if I can share screen now. What you're dealing with here is a person who's not very tech literate. So just let's keep our fingers crossed that this all works. And right now, I've got the screen up that I hope you guys can see. It's got the first slide on it. We may need to minimize the boxes on the right-hand side of the screen, so you'll be able to see all of the slides. If you are able to see the whole slide here, then that's fine. But if you aren't, we may need to be able to minimize the imagery on the right-hand side. And
I think we can see it.
All right, perfect. Okay, well, if you guys can, that's great. If there's a problem during the course of the talk, let me know. Let me quickly begin that by saying, Aaron said, there's good news and bad news. You're going to begin with the good news. He didn't put up and now for the bad news before he introduced me, so I'm hoping I'm not part of the bad. Part of the bad news is not that you're getting a lecture by me this afternoon. It's going to be a very conservative lecture. I believe firmly in the medical model and firmly in the thorough evaluation of the drugs that we use. So in a sense, you're not going to be exposed to anything unusual, and you can all relax and listen to what comes next. So I'm going to begin here with the Tobin versus SmithKline civil litigation trial. And in this happened after a man called Don Shell had been put on Paxil, and 48 hours later, he shot and killed his wife, his daughter, his granddaughter, and then killed himself. So this led to a trial, Tobin versus SmithKline, and the person you see here on the right is Ian Hudson, who at the time of the trial was the chief safety officer for GlaxoSmithKline, GSK. And he's being asked, can Paxil cause people to commit suicide? And his answer is no, it can't. We, GSK and other companies, bring our drugs onto the market using randomized control trials. This is evidence-based medicine. And our RCTs show that Paxil has no adverse effects at all. And he isn't the only person in GSK actually saying this. So the jury in the Tobin case looked at the case, listened to Ian Hudson, and came to the conclusion, to an evidence-based medicine conclusion, which was it was clear that Paxil was responsible for the deaths of this family. Hudson's views, rather than being defeated by that verdict, have ended up being ensconced to the top of the regulatory apparatus, FDA, EMA, WHO, at the top of groups like MRCT in Boston and Vivli. And Joe Biden and the Pope, for instance, will have a bunch of advisors who in response to the question, is Ian Hudson right, will say to them, yes, the answer to the press is yes, he is right. That RCTs are the way, the truth, and the light. Hudson himself became the CEO of the English version of FDA a few years after that. So when I say his views are ensconced right at the top of the regulatory apparatus, they are, believe me. So the origin of Hudson's views goes back 70, 80 years to this rather strange man, Ronnie Fisher here. Now, Fisher wasn't good on evidence. You see him here smoking a pipe. And when the link came out between smoking and lung cancer, Fisher poo-pooed it. Fisher had nothing to do with medicine, never ran an RCT. Randomization had been there before him and statistical significance had been there before him. But somehow what he did touched both of these concepts, picked them up, transformed them into something mystical, it seems, that again, as I said earlier, seemed to offer people a way through the confusions we have when we're using drugs. Fisher, in fact, was doing a thought experiment. He was trying to characterize expertise. Now, there's an area in which we're all expert. We all know parachutes save lives. So that if you had 40 guys up on a plane and gave 20 of them a parachute and the other 20 were left without the parachute and you push them out of the plane, we'd expect the 20 guys with the parachute to be alive on the ground and the 20 without the parachute to be dead. This would be pretty clear-cut. Fisher was saying that randomization can take care of some trivial things that an expert doesn't know about. It could be, for instance, that some of the folk have webbed armpits or webbed feet, and so when they're falling through the air, they don't fall quite as quickly, and this just might save them. And we need to make sure that trivial things like this are taken into account, and we do it with randomization. I say trivial because there can't be much that an expert doesn't know, and that's the key point. And the other thing that can interfere with this is chance. It could be that a strong gust of wind will blow one of the guys without a parachute into a snow-covered tree and he'll live. And this has happened. So Fisher said we can put a figure on this. We can say if 1 out of 20 actually survives, we don't discount the expertise of the expert. Fisher's expert is like Robin Hood. He can pierce the previous arrow, which has pierced the bull here 19 times out of 20 at least. Now, the problem is with the clinical trials that bring the drugs that we use across medicine, this is not just the antidepressant group of drugs, which I'll talk about mostly, the trials don't look anything like this. And they look so different that you'd have to say Fisher's thinking doesn't apply to what we're doing with what we call randomized control trials when we do them, okay? And in a sense, this is obvious because when we do these trials, we're not doing them as experts who know what the outcome is going to be before we do them. They're more exploratory. And this feeds into the next slide, which is, this in fact is the first randomized control trial in medicine. And it's done by a man called Tony Hill. And he's the person who put the link between smoking and lung cancer on the map. And Fisher and he didn't get on at all together. In this trial, Hill used randomization not as some mystical control for all of the confounders that can happen in the universe, but as simply a method of fair allocation. There was nothing more to it than that. The other thing you need to know about this trial was that there'd been an earlier trial in the Mayo Clinic that had looked at streptomycin for TB. And it was a much more clinically informative trial than Hill's trial in that it found that it worked, but that people became tolerant pretty quickly, and there could be problems. You could go deaf on this drug. So really, if you're going to use the drug, this other Mayo Clinic trial was a much better trial to be informed about. Now, here's Hill, and he's talking to a group of doctors 20 years later, and he's saying to them, we did randomized control trials in the early 1950s because nothing worked. There were claims for all kinds of things. We needed to try and sort things out and find if anything worked. But the 1950s have been extraordinary. They've given us a ton of drugs, the best drugs we've ever had, the antidepressants, the antipsychotics, the hypoglycemics, the antihypertensive, cortisol, cancer chemotherapies. And in many instances, we've never improved on these drugs. All of them were brought on the market without a randomized control trial in sight. So he's saying that actually the role for randomized control trials is not what it was when we introduced them first, but it's in order to try and find the best of these antidepressants, for instance, or the best antihypertensives, which is something that randomized control trials actually can't do. And I can come back to that later if you want. But the other things he's saying to the doctors there is randomization doesn't count. Double blind doesn't count. The point behind all these trials is to evaluate drugs, and anything that gets in the way of doctors conscientiously evaluating drugs is not helpful. The key thing is that you're engaged with the evaluation process. One of the other things he says, which is interesting, is, it's very strange, but the people going around the place at the moment encouraging doctors to practice according to the latest controlled trial evidence are pharmaceutical companies, which is the case with evidence-based medicine today also. But here's a point as well. He's saying, what RCTs can be very helpful for is establishing one thing a drug does, which by definition, in a sense, means they're not a good way to evaluate a drug, but they are good to establish one thing, whether there's a therapeutic benefit in a particular condition. Now, there was a wonderful trial that happened 5 years before Hill gave this talk, and that was done by Louis Lassagne, whom you see here, who had his formative years working in Harvard. And he had done some of the first randomized control trials in the United States and was the greatest enthusiast for them during the 1950s. And in 1960, he published this placebo-controlled randomized control trial of thalidomide, which shows very clearly that it was an effective hypnotic. It missed the nausea, the agitation, the suicidality, the sexual dysfunction, the peripheral neuropathy, all the SSRI-like things that this drug has. But it did establish the one thing, that yes, there is a benefit in terms of helping people sleep. Now, 2 years later, when the thalidomide crisis blew up, Lassagne was the key person who encouraged the politicians to bring randomized control trials into the regulatory apparatus in order to force companies to prove their drugs worked. And this was going to be a step to ensure thalidomide couldn't happen again. But the irony is that this is a step through which thalidomide sailed beautifully. We're going to come back to Lassagne later, but he's the person most responsible for us using RCTs. People who are advocates for RCTs say that this study design uniquely helps us establish cause and effect. Now, I've told you, most of the best drugs we've ever had come on the market during the 1950s without RCTs in sight, and imipramine was the first antidepressant and among the best. It treats melancholia in the way SSRIs don't. Melancholia comes with a high risk of suicide. But a year after imipramine came on the market, experts from Europe convened and had a meeting and said, this drug is great. We're going to be using much less ECT than we were using before. But there is a hazard. It can cause some people to commit suicide. You put them on the drug, they become agitated and suicidal. You stop the drug and the problem clears up. You reintroduce the drug and the problem comes back. So let's do a thought experiment. It's thought because, as I say, there were no RCT data on this drug back then, of imipramine versus placebo for melancholia. We'd expect the data to look a little bit like this. So this drug that can cause you to commit suicide in an RCT will look like the last thing it could possibly do is cause you to commit suicide. Now, contrast that with the trials that brought the SSRIs on the market. These are much weaker antidepressants. They weren't actually designed as antidepressants to begin with. And because of this, they had to be trialed in people who are mild to moderately depressed, who are at low risk of going on to commit suicide. And the data from the SSRI trials looks roughly like this. Now, I'm going to show you some imipramine data now, which is from real RCTs. These are not thought experiments, because imipramine was used as a comparator for the SSRIs in many of these trials, and the data for imipramine looks exactly the same as the SSRI data. Because it's been used in people who are mildly depressed, who are at no risk of suicide, so the suicide risk from the drug stands out. But the point I'm trying to make is you've got two imipramine sets of RCTs giving you just the opposite results. And what's going on here to some extent is we're thinking of these trials as drug trials, and they're not. They're treatment trials. And every time a treatment and a drug cause superficially similar problems, like both being depressed and on antidepressants can cause you to become suicidal, RCTs don't eliminate the confounding. They actually compound it. They make things worse. If you want to see the effect of the drug, you do a drug trial, which of course the companies did do, we call these phase 1 trials, where they gave SSRIs to healthy volunteers, and healthy volunteers committed suicide or tried to commit suicide. They had sexual dysfunction, pretty severe, and they became dependent on these drugs, so that after being on them for only 2 weeks, they could have awful problems trying to get off them, which gave the companies an opening to game the later treatment trials so that issues like this didn't show up. So just to nail the randomization bit a bit further, if you're invited, if you break a limb and are invited to get involved in an RCT of randomly applied plaster casts to one of your limbs, not necessarily the broken limb, this trial will beat placebo. Now, to practice evidence-based medicine on the basis of this trial would be crazy. You want to practice evidence-based medicine. You want to put the plaster cast on the broken limb for people, although there are exceptions to all this. But anyway, let me move on to something I hope you've all heard about, the James Webb Telescope, which apparently has, just in the news today, has actually established things that call the Big Bang into question. But anyway, I don't know about you, but I'm thrilled to the imagery that comes from James Webb. And I'm using it here to illustrate something, which is 200 years ago, the instruments that astronomers had weren't as good as this. They left people with a bit of confusion about whether they were looking at one star that seemed to be in slightly different places each time the telescopes they used looked at it, or whether they were looking at two stars. And the man who solved this was a guy called Gauss, who said, look, if it's measurement error, that should distribute normally. So we can create a confidence interval. And if the new measurement falls outside that, well, then you've got two stars, probably. So in the 1980s, and I hope you can see the names on the right-hand side there of the slide, a bunch of experts, almost all the experts in medical statistics came out and said, look, Fisher's ideas of statistical significance are all wrong. We need to get rid of this way of thinking. That's not what we do in medicine. We estimate things. We're not experts. We're estimating what's probably going on here. And we should be using confidence intervals. This article here just dates it for you. It's a 1986 article. So all of this thinking rushed in during the 1980s. And for those of you who don't know much about confidence intervals, here's two of them. When you do a trial, you plot the results from the trial out, and we've got two different drugs here, the red drug and the yellow drug. Both of the curves are on the right-hand side of the 1.0 line, which means that we're talking about a hazard here. And let's say these drugs kill you. So the red drug is very precise, and this is, at least the data looks awfully precise. And this is one of the things confidence intervals tell us. They tell us about the precision of the measurements we have. And in this case, 95%, 19 out of 20 data points fall to the right-hand side of the 1.0 line. So we can be pretty certain that this red drug does kill you. But one of the key things I've just said is that 19 out of 20 data points fall to the right-hand side of the 1.0 line. And what that says in essence is that confidence intervals in medicine are defaulting into a statistical significance test, which all the experts in medical statistics say we shouldn't be using. The yellow drug here, it looks like it's riskier. The chances of being killed seem to be much greater, but the confidence intervals straddle the 1.0 line. The conventional wisdom, there's two bits of conventional wisdom here that are both wrong. One is that if you're asked to take one of these two lethal drugs, most of the conventional wisdom would say you take the yellow drug because we don't know for sure that it will kill you. I would say you take the red drug. There's a much less chance that it's going to kill you. But the other thing is that precision's important, and I'm going to show you that that's wrong. But let me quickly take you here first, which is in 1991, a fuss blew up about Prozac causing people to commit suicide. And Lilly went and analyzed the clinical trials and said, look, when we look at adults and children and depressed people and eating disorders and other trials, you know, the confidence intervals you see here, and none of them are statistically significant. So we don't know that Prozac caused the problem at all, as you see in the quote here at the end. This is Ian Hudson thinking. This is the basis that underpins what Ian Hudson was saying. Our drug has no adverse effects at all. I think the consistency of the data across different groups of people points to the fact that there's a very real problem here. And the next slide or two is going to shake you, hopefully. In the trials that brought these SSRIs on the market in 1990 or thereabouts, you've got, here's the distribution of the data that happened in the trials. You see, under the word screening, there's 3 red dots. And what you've got here is people either kill themselves or tried to kill themselves, having been removed from the prior treatment they were on and being washed out before they enter into the randomized phase of the trial. This is a very risky period because you're withdrawing from prior drugs, and withdrawal can kill you. But when the companies submitted these data to FDA, this is what happened. That they said, well, look, in the washout phase, people were on nothing, which is the same as being on placebo. So we can move those events. They didn't move all the people down into the placebo arm, which might have solved the, well, which may have been a little more acceptable. They just moved the events down, and they made other maneuvers here, which you see. And even when they did all these things, there was an excess of suicidal events on active treatment compared to placebo. Now, around 1990, 1991, no one noticed this. Well, 1 or 2 people did, but very few people did. It came to public attention around 2004 when there was a crisis about children becoming suicidal on these drugs. And the press and all sorts of people got hold of this issue and just at the data that you've seen there and asked the companies what's going on. And the response from GSK and Pfizer that you see here is, well, we were completely transparent. You can see what went on. FDA could see what went on, and FDA didn't say anything at all. Now, I have to tell you, internally in FDA, what the companies did here breached regulations. And there were memoranda from FDA staff saying, look, what's happening here breaches regulations. But FDA paid no heed. And not only that, but senior people in FDA like Tom Loughran wrote articles that endorsed the maneuvered or manipulated data that you've just seen. He said, this is what the data looks like, when making a case that it was not unethical to use placebo in controlled trials because people on placebo are at no greater risk of going on to kill themselves than people taking active drugs. So there was a lot of back and forth between companies and FDA around 1990, 91. Was what happened criminal? Well, perhaps, but I prefer the idea that we've got strategic ignorance at play here, which is FDA are not in the business of knowledge creation. They're bureaucrats, they're not politicians. Companies are in the business of knowledge creation. Doctors, when it comes to medical knowledge, should be, you'd have thought, taking the lead in knowledge creation. But around 91 or so, a lot of doctors had just gone missing in action. Now, in the next 3 slides, they contain an image from GlaxoSmithKline that you're not going to be able to read the small print all that easily, but I'm going to email all of the slides and the text that goes with it to Aaron, so you'll have a chance to look at everything in detail later. I just want you to focus on the bottom line. The 2004 crisis led FDA to ask the companies to send them all their data, their adult data as well. And when you look at the adult data for GSK's major depressive disorder trials, this is what the data looks like. Paxil causes people to commit suicide. Even Ian Hudson would have to say it did. And in fact, he had access to these data before the Tobin trial when he said there are no adverse events on our drug. Randomization came to Ian Hudson's rescue and FDA's rescue and everyone else's, which is GSK did 2 trials as well in intermittent brief depressive disorder patients who could be admitted to MDD trials as well. And the other line in bold at the bottom gives you the data from the IBDD trials, which again don't look particularly good for Paxil. But the really intriguing thing is when you add these 2 lines in bold, the data from the 2 lines in bold at the bottom together, what you all of a sudden get is that Paxil protects you against suicide. Now, the point here when I said that IBDD patients could be recruited into MDD trials, no problem, is that this is an effect that will happen in every medical condition that's heterogeneous, and that's dementia, diabetes, Parkinson's disease, breast cancer, osteoporosis, back pain, you name it. Almost every medical condition we have is heterogeneous. And in this case, the heterogeneity is going to hide the effects of the drugs, and it lets us use the adverse effect that a drug causes to hide the adverse effects that a drug causes. Let me show you the confidence intervals for that. The one at the top is the MDD trials, and this is statistically significant. The yellow curve at this point is the IBD and MDD trials put together. And the conventional wisdom, as I told you earlier, was if we just add a few more patients into the broad spread above, the red drug, that we should be able to make things more precise and know what's going on. And we have just added a few more patients into the overall mix, less than 5% more patients in here. And what we've done is we've shifted the curve entirely over to the opposite side of the 1.0 line. We've made it more precise, but this precision is an indicator of our ignorance, not that we have a better knowledge of what's going on than we had before. We can also do something like this. If we had 20 Aaron clones who all, when they were exposed to Paxil, actually fall asleep, and 20 David Healy clones who, when they're exposed to Paxil, all wake up. And we ran that trial, so we had completely different results on either side of the 1.0 line. The best estimate of what's going on is that the top of the curve you see there would lie on the 1.0 line. And in this case, we'd have a situation where a method that should help us distinguish between either, is there one star here, or are there two? The answer is that there are no stars. So this is not clever. It suggests that confidence intervals applied to medical trials, that they're no more better than what the experts say, which is that statistical significance isn't good or helpful. Why do we hang on to these things? Well, one of the reasons we hang on to them is that regulators, for sure, companies, yes, and even doctors like a stop-go signal. And when things are statistically significant, we think we can go ahead and do things that, we don't have to think anymore. One of the other things to quickly bring in about confidence intervals before we leave them is young men often use a drug called finasteride to help their hair growth. And we could do a trial counting hairs, literally, before the drug and after the drug, and show with confidence intervals that, yes, it's absolutely clear this drug causes an increase in the number of hairs you have. It also causes you to commit suicide, and it also causes it can wipe out your ability to make love ever again in your life. Finasteride, like most drugs, has 3,500 effects. In a clinical trial, we just look at one of them. We count hairs in this case, and we don't collect the other data. So we may have bits of data. There may be a person or two in the trial that's gone on to commit suicide. And when Merck apply a confidence interval to that, they say, there's no clear signal here. Our drug doesn't do it. This is best called a confidence trick. Now, I've told you that in the case of the SSRI trials, more people die on these than on placebo. The outcome measure in these trials is not people who are alive or people who are dead. It's changes on the Hamilton rating scale score. And the most famous depression rating scale score is the HAM-D. And here's Max Hamilton, 15 years after he creates what he called or thought of as a checklist, not a particularly scientific instrument, just things you should remember to ask. He's saying, things like this are going to standardize clinical practice. And this may have a good side, but it might also have a bad side to it. And here's the bad side. Up to about 1980 or so, we were in the business of trying to help people with the problems they brought us in order that they could get on and live the life that they wanted to live. Afterwards, using rating scales like this and other measures, as you'll see, we ended up in the business of helping people to live the life that Pfizer wanted them to live. Using a scientific rating scale in quotes will look better to the people who run health services these days than me asking you about the football results or recipes or holidays with your family. But on the rating scale, you've got things like the suicide item. And if I adhere to the rating scale and asked you, did you try to kill yourself recently, or think about killing yourself, and you say, yes, I tried twice in the last week, I'll score you as a 4. I won't make a judgment call about whether it was the drug that caused this, in which case should score you 0. And half of the items on the scale are things that the drug can cause rather than the illness. And if you're just totting things up, you're going to come up with a higher score when things have been caused by the drug, and you're going to think, I need to increase the dose of this drug or add in more of one company's drug or another, which is getting you to live the life that they want you to live. Now, lots of people think RCTs will be okay if only they were run by angels rather than by industry. I don't think this, but introducing industry here is not because I want to paint industry as the scurvy knaves that are responsible for all things going wrong. This is a great trial. This is an industry standard trial. This is study 329, which looked at Paxil in the treatment of teenagers who were depressed. And it was run in the best university centers in North America, with an authorship line to die for, with the first author, Marty Keller, and the article comes out in the journal with the highest impact factor in child psychiatry. It says Paxil is safe and works well for teenagers who are depressed. Internally in SmithKline 3 years earlier, they had concluded when they were the ones who first saw the data that our drug doesn't work and it's not safe. How are we going to handle this? We can't publish the results as they stand. We're going to pick out the good bits and publish them, and that's what you see in the Keller article. Now, this is a 6-page document which you're all welcome to if you want. When it found its way into the hands of New York State's Attorney General, he took a fraud action against GSK. It also played a part in a Department of Justice action against GSK, which was resolved for $3 billion. And it helped me and a few colleagues get access to the data from Study 329 and to write it up the way we thought the data looked like they should be written up. Or interpreted is the word I'm going to use, and you'll see why now in a moment. So we got access to more data than FDA ever sees from any of the clinical trials that it's asked to review. The Keller paper reported on the data from the first 8 weeks of this trial, and you see the first 8 weeks here in our hands. We could see no difference between the 3 treatment arms. The Keller paper in GSK never published the 6-month follow-up data. We did, and this is 18 years after the trial had actually finished. And again, you see no difference between the 3 arms of the trial. So the interest in the paper is not about does the drug work or not. It doesn't really work. The interest is in the Keller paper, if you read it, there were 6 children described as becoming emotionally labile. Now, neither I nor anyone else that I know of knew what that meant. You could figure from the small print that maybe some of these emotionally labile children became suicidal. In our hands, when we got access to it, there were, in the Keller paper, it looked like 4 of the emotionally labile children were taking Paxil. In our hands, 18 of the 93 children on Paxil in this trial became emotionally labile. And emotionally labile meant suicidal, homicidal, manic, and other serious behavioral problems. And if you want, although I don't think you should pay any heed to it, these data were statistically significant. But, and here's where I want to hop for a second to a Pfizer trial happening around this same period, where a man on the active treatment became agitated and poured gasoline on himself, intending to kill himself, set fire to it, but only died from his burns 5 days later. Now, Pfizer coded him as death by burns. When a person dies in a clinical trial or goes into hospital, companies have to write a narrative report about what happened so that FDA can read it and work out, well, actually, this should have been suicide. I mean, when you read the report, there's no real question, but that this ought to have been coded as this man tried to kill himself. I don't know if FDA ever did read it, but I do know in the case of 4 children in study 329, they didn't read the narrative reports because there weren't any there. And this isn't actually one of the children in study 329. It's just an image to help me tell you that one of the 15-year-old boys in this trial taking Paxil 2 weeks after he goes on it is out on the street with a gun, waving it around and threatening to kill people. This is Dallas, Texas. He gets picked up by the police and he gets brought to hospital. So there should have been a narrative report for this serious event and the fact that he goes to hospital, but there is none. FDA don't know about this. They know nothing about what happened to this boy or the other 3 children where the same thing happened. There were no narrative reports. And in the reporting of clinical trials in the New England Journal of Medicine and other major journals up to the last few weeks, you can see in these trials that companies are still availing of a loophole that they discovered 30 years ago, which meant that they don't have to write narrative reports. And either FDA doesn't know about the loophole or FDA and the companies don't want to close it. If you want to know more about the loophole at the end, ask me and I'll tell you. But what I want to tell you here is more interesting in a way. On the right-hand side, you see the last 3 sentences of the paper that we wrote. And essentially translating these, it says, look, we've got into thinking of articles about randomized controlled trials, a bit like Moses bringing the tablets down from the mountaintop. They tell us what we should be doing. They command doctors to prescribe and they command patients to take. But when you get access to the data, you realize that actually the data doesn't underpin commandments, and scientific data should never underpin commandments. What it does is to raise more questions. And one of the interesting questions, and people don't think of this as being intrinsic to the scientific exercise, is the editors of the BMJ had awful problems, not with the data that we revealed. Their problem was with our interpretation of the data. Let me explain. Coding. The emotional lability coding was a legitimate code that GSK had used from a dictionary that FDA knew nothing about and didn't have any access to. We used the standard dictionary for coding in the field, but no one reviewing an article like this ever asked, well, how is the coding done and how legitimate was it? This is the first act of authorship, but as I say, no one ever reviews it. The next act of authorship is the word grouping here. There were, in the 93 children taking Paxil, they had 500 adverse events. You can't report 500 events. You group them into the cardiac events and the respiratory events and the behavioral events in the case of children going on to become suicidal. GSK grouped the behavioral events under neurological, and this mixed them up with headaches and dizziness that are awfully common and drowned out the behavioral signal. If you remove the behavioral events and put them in a behavioral group as you usually would, then the signal between the 3 different treatment arms was very, very clear. But the editors of BMJ had a problem. There's one thing to have raw data. It's a different thing to interpret it. And they really wanted us to write the paper the way GSK had interpreted it because they couldn't see a legitimate basis for a different interpretation, which is key. And this is key to all trials and FIVLI and a few operations like that. Interpretation, which people don't usually think as being part of the scientific process. Well, I'm going to come back to that and say it's key to the scientific process. Here's a bit you may not know, which is everybody knows that FDA approved Prozac for teenagers who are depressed, but not any of the other drugs. Well, here's part of an approvable letter. And again, you can have the full letter if you want. It's FDA saying to GSK, we agree to approve Paxil for teenagers who are depressed. We agree, you've told us study 329 and these other 2 trials you did in teenagers who are depressed were negative, and we agree with you, they're negative trials, but we're still going to approve the drug. And we also agree with your proposal that it would not be a good idea to describe these negative trials in the labeling of the drug. I should tell you quickly that FDA reviews of Prozac for teenagers who are depressed were negative, like study 329, but they still approved it. And the approval went through before the crisis blew up. So that's why there's an apparent approval of Prozac and nothing else. So in 2008, there was an article by Eric Turner and colleagues looking at the publications on the trials of antidepressants that we know and love, and they're all universally positive, saying the drugs work well and are safe. Look at the column 3 from the right, the sertraline column with the figures 61 and 62 in it. You've got to have 2 positive trials to get approval from FDA, and there's the 2 trials. But Eric Turner, in addition to being able to access these articles the way we can, had worked in FDA and knew about med reviews of these drugs. And you may all know this, but here's what it looks like when you look at the med reviews of these drugs, which is 46% of the trials are negative. That there's a number of trials that were negative and never published, but more worryingly, there was a third of the trials that were negative, FDA viewed as negative, that are published as positive, like study 329. And that's more worrying, really. But why are FDA saying nothing about the positive publications of negative trials? Well, you know, they and the companies must know that if they put that into the labeling of the drug, the company might get sued for fraud and end up being fined billions of dollars by the Department of Justice. So it doesn't happen. Look at the sertraline column 3 from the right. There's only 1 positive trial there now, and it needs 2 positive trials to be approved by FDA. Here's the sertraline PTSD data. They'd run 4 trials, all negative, but FDA approved this drug for PTSD on the basis that there were marginal benefits for women in 2 of the trials. If you see under status, and again, you can have this slide, it says these 2 trials have been written up. One's going to the New England Journal of Medicine, the other's going to JAMA. Author TBD is over on the left, to be determined. Pfizer's marketing department will work out who the authors should be. Now, this is true of all articles of on-patent drugs across medicine. It's not just an antidepressant issue. They're all ghostwritten with no access to the data, for the ghostwriters are the notional authors. In the case of study 329 that you saw, there were 24 authors. The real author is not listed there at all. Okay, I mean, she didn't just write the article, she wrote the cover letter for submission to the journal. So this is true across medicine generally. In the case of children's trials, we've got 100% of the literature that gets published that is ghost or company written. And we've got the greatest divide in all of medicine, I think, between what the publications say on the one side and what the data when we've got access to says on the other side. It may even be the greatest divide in any branch of science currently. So where's FDA in all this? Well, FDA, what you may not know, what you guys don't have to think about, you know, you've got your Boston Tea Party, but well, England had its European Chocolate Party. When they joined the European Union 50 years ago, they ran into trouble instantly, which is that, you know, the Europeans told them, you can't call your favorite chocolate chocolate. It doesn't, that's your favorite Cadbury's chocolate. It doesn't have enough cocoa solids in it. And this is what FDA do. They regulate food and drugs. They regulate whether what's been called chocolate has enough cocoa solids in it to be called chocolate, whether butter has enough of a particular kind of animal fats, and whether in the case of antidepressants, there's a small fall on a Hamilton rating scale score. And if there is any of these things, then FDA lets you use these words. They're not in the business of trying to say this is good chocolate. They're not in the business of saying butter is good for you. They're not in the business of saying antidepressants are going to save your life. And they're certainly not in the business of policing the medical literature. What they are in the business increasingly of doing since the 1991 suicide crisis on the SSRIs is saying that we approve drugs on a benefit-risk basis. Now, if FDA were asked to approve parachutes with 20 living people on one side and 20 dead people on the other side, even though in the case of the men who are alive, they may have trouble making love for the next week or 2 because of harness effects, we'd still say there's absolutely for sure a positive risk-benefit ratio here. But when FDA are approving SSRIs where there's more dead bodies in the SSRI arm of the trial, and where every single person who takes an SSRI within 30 minutes of their first pill will have genital changes, and nobody will be making love the way they made love normally before they went on these pills while they're on the pills, and are expecting to be able to make love normally when they come off the pills, but often can't come off the pills at all, or if they do, they are never able to make love properly again. And all of this has gone missing from the SSRI trials because the companies have known how to game these trials so it doesn't show. We're left with a situation where FDA are making a benefit risk claim. It can only mean that they're encouraging us to live the life that Pfizer and Lilly and GSK want us to live, rather than informing us in a way that would let us live the life that we want us to live. Let me illustrate this with a patient I had a while ago who had OCD, for which SSRIs are the first line of treatment. We put him on an SSRI, didn't work for him. We put him on some more heavy duty drugs, didn't work for him. And this was a man who needed his OCD cleared to be able to work. He came back a few weeks later to me, and it was clear he was cured. He was happy, and he'd stopped all the drugs that I'd put him on. But that's not what cured him. He'd gone back smoking. Now, I often say the art of medicine is bringing good out of a useful poison, and people hiss at me when I say this. Doctors hiss at me. In this man's case, probably people would agree. He's bringing good out of the useful poison, a poison that's available over the counter because we think they're less poisonous likely than prescription drugs, which are on prescription only because they're riskier than alcohol and nicotine. But my key point here, well, one of my key points here is this man is in a position to make a benefit risk call. Benefit risk calls are an individual thing. FDA can't make them on the basis of some average people. It just doesn't work. It's an individual thing. And the other thing, just to let you know about, it's a nice point, which is just in case you're thinking he's putting too much weight on a citizen research, and this man was just a heating engineer. He had no background in healthcare. Well, when he came along to tell me that going back on nicotine had helped, he said he'd Googled nicotine and OCD and found a bunch of trials which show that nicotine can be very beneficial in OCD. And he handed me a bunch of articles, and he was not to know that the first article that he handed me had an authorship line that included Arvid Carlsson, who won the Nobel Prize for Medicine and discovered the SSRIs, and is an author on a paper saying nicotine is a good treatment for OCD. So the point behind this is, when it comes to a problem that people have skin in the game with, motivation is worth at least as much as expertise. This is back to Ian Hudson. 25 years ago, I wrote this article here saying that everybody who enters into a company trial, because of Ian Hudson thinking, which is that RCTs show that our drug has no side effects, is putting everyone else in a state of legal jeopardy. We shouldn't get involved in these trials until that changes. 25 days ago, this article of mine got published, and this is saying people who are currently being seduced into clinical trials because the consent form says that if you are injured at all in this trial, we have insurance policies to ensure that you get the best possible treatment, etc., etc., etc. This is, I'm not sure what quite the right word is, fraud, or whatever. I'm just not sure. Maybe you guys will know. But it's on the basis of Ian Hudson thinking, which the companies have no intention of acknowledging that you've been injured in their trial. There's only one place where Hudson thinking doesn't apply, and that's if you're an investor in a company and want to work out what you think of the benefit risk ratio. You're told by the company there are no adverse effects on our drugs. These haven't been established, but you want to see the data and make up your own mind in terms of the benefits and risks of the investment you might be about to make. The Supreme Court of the United States in 2010 said you have a right to see the data and make up your own mind. So the telltale heart, the beating heart of this talk lies in this article from Boston clinicians, 3 of them, 33 years ago this month, where these 3 clinicians described the cases of 6 people who became suicidal on Prozac. Now, in terms of establishing things by the rules of medical causality that existed then and exist still, this article nailed it. Prozac can cause some people to commit suicide. Now, about 20 other groups jumped in and said, we've seen the same thing, including a group from Yale who said, yep, we gave this drug to kids. And 1 in 7 of them, I think, they said they became suicidal on the drug. I had an article too. I was one of the people in the mix with 2 men who had become suicidal on the drug that it couldn't be explained any other way. This was evidence-based medicine. You gave the drug, the problem appeared. You stopped the drug, the problem cleared up. You reintroduced an SSRI, the problem comes back. In almost the same week that my article came out, Lily's article, which you see here, was published in the BMJ, saying, we've meta-analyzed our RCTs and there's no evidence from these that Prozac causes people to commit suicide. The cases you're hearing from Martin Tauscher and David Healy and people like that are very sad, but they're just anecdotes, and the plural of anecdote is not data. It's depression, not Prozac, that causes people to commit suicide. And the challenge to everybody was, well, are you going to believe the science or the anecdotes? The challenge to the media, the public, the politicians, doctors, are you going to believe the science? Well, there's a contrast. I mean, this is the first article of the evidence-based medicine era. This creates evidence-based medicine. The contrast is with evidence-based medicine, which is Martin Tauscher and me in particular. Well, there's no clash, as far as I'm concerned, between evidence-based medicine and evidence-based medicine. And when you realize Lilly cooked the books and get access to the raw data, you see actually their trials show that Prozac causes some people to commit suicide. No question about it. So there's no clash there. But even if there was a clash, even if there was an incompatibility, this is the stuff of science, resolving incompatibilities like this. Lilly are not being scientific. They're being religious. They're being dogmatic. They're saying there's only one way to the truth. We're not in the business of trying to reconcile anything. You know, people who are coming out with anecdotes, you know, they're all wrong. I should have told you that the original of the phrase, the plural of anecdotes is not data, was the plural of anecdotes is data. And without that, Google wouldn't work. In the case of the healthy volunteer trials they did, you know, companies will get experts to say the healthy volunteers that committed suicide must have been diseased, but I think it's more likely it was the drug that caused it. And what, you know, the challenge I'm putting to you is, are you going to believe the science, which is evidence-based medicine, or are you going to believe the artifact, a version of the truth that can be conjured out of dodgy statistics, which are not necessarily applicable in this case? Lily's approach is paper infallibility rides again, or as Peter Drucker would say, you know, the goal of marketing is not to sell Prozac, it's to gain ownership of the marketplace. And this is the article that gained ownership of the marketplace. Now, I'm contrasting religion and science, which takes us back in the history of science to the establishment of the Royal Society, which is where our usual stories about the origins of science come from. And this is a group that famously said, look, we're not in the business of discussing theological questions or philosophical questions. We are interested in questions that can be settled by data. Whether you're Christian, Hindu, Muslim, atheist, or Jew, you leave all of that stuff at the door. You come in and look at the experiment taking place in the apparatus in front of you, and you've got to come to a consensus view about the best way to explain that. When this history is told, the emphasis is usually on the word data. My emphasis on the word settled. This is the key thing, the consensus settlement rather than the data, because there was no data in the early experiments. In the early experiments in science for 250 years, there were very little data, certainly no statistics. They were looking at events. Now, there's an event that happened 40 years before this, which is awfully important here, which is the execution of Walter Raleigh for treason. After he died, the English legal system said, well, he was convicted on the basis of hearsay, things that people said he had said and said he had done, but people who were not prepared to come into court to be examined and cross-examined. So the rules of evidence changed, which is a jury of 12 people, whether Christians, Hindus, Muslims, atheists, or Jews, were told to leave all of that stuff at the door and come in and make a judgment about the best possible way to explain material that's put in front of them, which they could see being examined and cross-examined, which is the essence of science. Now, let's say 30 years ago, Aaron had come to me and said, look, he's feeling dodgy. He's heard about this new drug, Prozac, and he's wondering whether I can give it to him. And I do. And a week later, he comes back and says, I feel weird. I think I might kill myself, which is very unusual for me. And we halt the drug and the problem clears up. And maybe we're brave and we reintroduce it and the problem comes back. We've got access to all of his medical records and labs and things like that. And we can run a case conference with all of you guys here and let you ask him any questions that you want in order to work out what's going on. And if at the end of the day, our consensus view is that the best way to explain this is Prozac caused it, and we think we'll file a report with FDA about all this, the first thing FDA will do when the report about Aaron's becoming suicidal gets them is they'll remove his name. They'll convert it into hearsay. And let's say 30 years later, I'm treating one of you with an SSRI and you become suicidal and you want to take a legal action against me. And you say, well, look, there's tens of thousands of reports of people becoming suicidal or trying to kill themselves on these drugs. My lawyer will say, that's all hearsay. You can't bring it into court. There's no one that we can identify you can bring into court. My lawyer should also be saying, of course, but he possibly won't, that company trials are also hearsay, that often the patients don't exist. There's no patients that can be brought into court. The authors on authorship lines increasingly are people who have never seen any of the patients who've been in these trials. There's no one that can be examined and cross-examined in front of a jury. But if Aaron and I had written up his case and published it in the American Journal of Psychiatry or the New England Journal of Medicine, you would be able to bring us into court because our names are there. So this is a key point, it seems to me. I should have had this up while I was going through all of that with you, which is, this is Louis Lassagne around early 1980s. And I'm not going to read all this to you. I hope you can read it. He's facing the first claims, and this is the early 80s, when actually, if we're trying to establish the adverse effects of a drug, like do people become suicidal on Prozac, clinical trials are the sophisticated and scientific way to do this. And Louis introduces this beautiful meaning of the word sophisticated when he says, well, that may be true, but in the meaning of sophisticated, which means adulterated. When we sophisticate wine, we adulterate it. Essentially, he's saying that the way Healy and Kesselheim have gone about trying to work out whether Aaron Kesselheim was caused to become suicidal by Prozac is the scientific way to do this. Now, when you see Louis Lassagne here, he moved back to Boston soon after this. He was thought of as having been pro-doctor, and he still was, but probably had become too close to the pharmaceutical industry. So this is not a person who is hostile to industry. And here he is toward the end of his career, 15 years later, saying, in the 1950s, I went around the place trying to convince people to do controlled trials. Now I'm saying, forget it. This is very like Tony Hill, he's saying, both of them are saying, look, controlled trials, one of the things they do, I forgot to say this to you earlier, one of the things Hill said was, they don't tell you how to treat the person in front of you. They tell you something average about the drugs, which is not good for a doctor trying to treat a person, and is not good either when you're trying to establish whether a drug causes a problem or not. So to come back to the James Webb Telescope, I'm thrilled to it because it shows us the individuality of zillions of stars. Confidence intervals, when they were used here early on, have led us on to a picture that has promoted an appreciation of individuality. Somewhere in the last 50 years or so, we've got this idea that using chance to control bias leads us to an objective statement about things. My view is the other way around. What we're doing, the scientific method for the first few hundred years of science across the board, the method in law and the method in clinical medicine is using bias to control chance. And this is extremely important. I'm getting towards the end of the talk. It's extremely important when numbers come into clinical medicine, as they did in the early 80s. Up till 1980, we were in the business of treating people with heart attacks, strokes, psychoses, and mobilizing the resources of the organization we worked for to help them with their problem in order that they could get back to live the life that they wanted to live. What industry found in the early 80s was we could treat healthy people with drugs, and that's where they make their money. They're not in the business of making drugs to treat the diseases we have. They're in the business of treating us when we're healthy for risk factors, for numbers. They're encouraging us to treat numbers for all of the conditions you see here. And part of the problem is brought out by the weighing scale image, which is weighing scales for people were introduced in France in the 1860s. 10 years later, you got the first description of a new illness, anorexia nervosa. Weighing scales migrate into drugstores with a plate on them telling you your ideal weight for your height and sex, and eating disorders mushroom. Weighing scales migrate into our bathrooms in the 1960s, and eating disorders explode in countries that use where people weigh themselves. When we've got numbers like this, it's terribly hard not to be neurotic, not to respond to them. It's even harder if there's an algorithm giving us a judgment about what we should be doing rather than us being able to make up our own mind. And this interfaces with another change that happened in the early 80s, which was that what had been healthcare, where clinical discretion, a doctor's judgment was a bit like a judge's judgment. It was a thing that kept the whole thing going. Healthcare became health services industries. It became part of the service industry, and it got managers for whom the idea of trying to bring good out of the use of poison simply didn't compute. So where patients before felt the resources of the organization been mobilized to help them, increasing their experience after 1980 was that the doctor they were facing was trying to contain the risks that they might pose to the organization he worked for. Now, as managers, our technocrats would tell you, we manage what we can measure. This is the essence of neoliberalism, where we could measure the inflation rate in the UK or Chile, we could measure the money supply, and we treated those rather than the country. The country could go to rack and ruin. In the same way in medicine now, we're treating numbers, and it can be disastrous to the people we're treating because we're putting healthy people on a bunch of drugs which are not vitamins. So in medicine, I think you can see most clearly neoliberalism in action and the deleterious effects this can have. We're producing with numbers a sheen of scientific gold to coat the things we do in health services, but it's a modern version of the King Midas myth, where we're producing a situation which is incompatible with human care and life. So the lady in the middle is a pilot. When she sees things going wrong, she reports it and the system changes, because if they don't, she's not going to fly again. The lady on the right, Jane Fraser, who's the CEO of Citibank in New York, and her rise to the top came during the middle of the financial crisis. Banks now have an early warning system. I don't know if it works or not, but there's general agreement that in the case of banks, that what bankers were doing was outsourcing risk, dodgy mortgages, which could blow up in our face, but there were no consequences for the bankers. They could still collect their bonuses. The lady on the left's a doctor, and when she reports an adverse event, the system pays no heed. She also outsources risk. Drugs that look too good to be true, like mortgages that look too good to be true, she puts them in our mouth, and if we explode, she sails on without any consequences for her. This is a situation of moral hazard, which makes it terribly hard for a doctor or a banker to do the right thing, particularly if it involves bravery. Now, like the bankers put us into a financial crisis, doctors look like they're putting us into a pharmaceutical crisis. Here's life expectancy in the United States. And if you see around 1980, when we began treating numbers rather than people, when we converted from healthcare to health services, life expectancy has been falling ever since. And this data is pre-COVID and pre-vaccines. The best way to explain it, I think, is polypharmacy. Drugs are like guns. That the country that has the best drugs and guns does the best. They create an arms race, and the country that wins the race wins. And the military has a huge input into health services as well as armaments for this reason. Drugs are like guns in the sense of if they proliferate too much, we figure that this may not be a great idea and things could go wrong. But the morality of drugs and guns crucially hinges on us rather than lies in the drug or the gun. There's a further factor here, which is in the case of guns, they do truly improve, but there is a limit to effectiveness, which is we can produce atomic bombs, which are too effective to use. In the case of drugs, it's the same. Once we go beyond 3 drugs for each person, you begin to lose the effectiveness you could get from each drug. Plus, there's another factor in the case of drugs, which is a drug is a chemical, which is always risky, and we're not producing better and better chemicals. It's a chemical combined with information, and we're producing worse and worse information. It's where our propaganda techniques are most clearly, obviously improving, to the point where the greatest concentration of fake literature on earth probably centers on the drugs a doctor gives us. And that can't have a good outcome. And it's not moral either. There's no way to make good propaganda work morally, I think. But anyway, in the US 6 years ago, 40% of over 45s were on 3 or more drugs. 40% of over 65s were on 5 or more drugs. We know that in the case of many people on 15 or 10 drugs, if we can get that down toward 5 or 3, we reduce the rate at which you go into hospital, we increase your life expectancy, and we improve your quality of life. But this is not easy to do. I told you that we used RCTs in the 1950s because nothing worked. Tony Hill thought we might use RCTs to try and pick out the best drugs. But in the situation we have now, the greatest medical need is to reduce the burden of meds we're on. RCTs can't help us. There's never going to be an RCT that helps a doctor reduce medication burden any more than help this guy here in the Hurt Locker movie defuse bombs. There's going to be no guidelines. If the doctor has a walkie-talkie and can talk to clinical colleagues, that's great. If they've got clinical experience with defusing bombs, that's great. But the critical person to relate to is the patient they're treating, who's got the experience of being on these drugs, who's every so often missed a pill and knows which ones they can get by without. A lot of these drugs are life-threatening when you try to halt them. Some of them just can't be halted at all. And the other thing about the person you're treating is their values count. What do they want from the life that they've got? Okay, this is a key point. The other aspect to this, which it may not be a North American, well, may not be a United States thing other than culturally, is if you look at Canada and Europe, the idea was, once upon a time, it was a privilege of wealth to get treatment to save your life. And so systems, public health systems, have wanted people who aren't wealthy to not be disadvantaged. So they're in the business of giving you more diagnoses and more drugs, as many as you like. This is the way the system's engineered, up to and including medical assistance in dying, which you see here, which Canada now leads the way in. There's young women who get euthanasia for treatment-resistant depression, which I think is likely often caused by the cocktail of psychotropic drugs they're on, rather than it being a condition that they had to begin with. But that's a thing to be concerned about. But my moral concern here with the Canadian system and the European system, and I don't know about the US other than culturally, which is that it's now a privilege of wealth to get off drugs. If you try and take a medication burden reduction approach in Canada, the system reacts against you and will give you the sack. So just to end, King Arthur was out riding in the forest one day and met a black knight who challenged him to a duel and beat him and was about to kill him when he said, I'm going to give you a riddle, and if you can answer this, and when you come back in a year's time, I let you live, and if you can't answer it, you die. And the riddle was, what do women most desire? A year later, Arthur and his court don't have an answer, and he's on his way back to die. And they meet this lady on the edge of the road who says, I've got the answer to the riddle, but you're going to have to give me one of your knights as my husband. So Sir Gawain jumps down and says, I will be this lady's husband, your majesty. Arthur gives the Black Knight the answer to the riddle, who lets him go, and they all head back to court, where a few days later, Gawain and the loathly lady get married. And you see that everybody in the court is looking glum about this and perhaps wondering what's going to happen when they go up to the bedchamber. Well, what happens when they go up to the bedchamber is that she takes control of the situation. He can't bear to look at her. She taps him on the shoulder, and says, I have a riddle for you. Do you want me to look like this in the bedchamber with you at night and the way I was looking in the court during the day? Or do you want me to look like this in the court during the day and the way I was looking in the bedchamber with you? And he has no idea what the right answer is and says, whatever you want, which is the right answer to both riddles, which is we all want, as this lady does, to control our own lives. In her case, she may have a problem that medical treatment will help with, but ultimately she may know more about living life than any of the doctors she comes to see. If the doctors practicing according to evidence-based medicine, they're going to be dealing with an average person, not this lady, and creating a false we. The only way to be scientific is to recognize that she is the apparatus in which the experiment's taking place, and you've got to look at her and listen closely and mobilize the resources around you, taking her into account in particular. Now, as you do that, she looks more interesting. She may tell you about nicotine and OCD, for instance, and you learn to appreciate her more. And as you do that, she appreciates you more, and we build an us, we build a community. This is the essence of science. This is the essence of democracy also. Thank you.
All right. Thank you, David. That was very interesting and provocative. And we've got about 10 minutes if people want to try to ask some questions.
Do you want me to tell you about the loophole that companies have?
Why don't you, if you can unshare your slides, then we can see each other a little bit.
Oh, sure, of course, absolutely. Yes, good idea. Huh. Right, okay.
Great.
Thank you for a really thought-provoking presentation. And I'm wondering about the Paxil studies that you were discussing.
Yeah.
And the example is so striking that it's unclear to me that it shows us that RCTs fail to show effects of medications, but rather that when companies mask the data and the findings from those studies to put them in their favor, then we have problems. And
well,
so
no, all right, okay. Yeah, no, but I think you see, I'm not against controlled trials. I think drugs need to be evaluated. But like the Mayo Clinic thing, where they didn't randomize, they didn't double blind, they gave the drugs to people, and seasoned clinicians evaluated what's happening. So that's not an issue. And when you do that, you see in the trials that companies do, which are not designed to inform clinical practice. They're designed to get on the market. They're assay systems rather than trials. The other aspect of this is, you know, when I said that trials can't tell us, as Tony Hill hoped they might, that, you know, what the best drug is. The problem is there was a great NIH trial running during the 1960s looking at the treatments we had for diabetes, and they were looking at, well, type 2 diabetes. It was looking at insulin, for instance, and what's the anti-diabetic agent that begins with M? Forget the name, but
Metformin.
Yes, metformin. Yeah, and they were looking at a new they were looking at tolbutamide, which was the on patent drug, and looking at stimulants also to suppress your appetite to see would this work. The trial took 10 years to execute. It had an endpoint which was mortality, okay, which is just what we want. This is a clinical trial designed to inform clinical practice. Tolbutamide, which was the on-patent drug, came out worst. Now, what we've got here is a situation where it's not clear that that means you shouldn't use tolbutamide. It's a bit like a trial for back pain where, you know, analgesics are always going to beat antibiotics. But if I've got a back pain and it's linked to a bug in my back, then the antibiotic is the right treatment for me. In the case of tricyclic antidepressants. They are vastly superior in terms of efficacy to the SSRIs, but an SSRI may be the right drug for me. So, you know, the idea of a best drug doesn't compute. There's drugs. We want the widest range of drugs that we can have on the market, with doctors and patients being as informed as they can be about these drugs, trying to work out in each of our cases which might be the best drug for us, rather than being told by a trial, this is the best drug, which may not be the right drug for me. So we've got, I mean, you have to appreciate here, I'm not saying we don't evaluate things, but we've got to the point where we're thinking that randomized controlled trials can do the evaluation for us. They can't. The evaluative exercise depends on the doctor meeting the patient, and suspending that with checklists and surrogate outcomes and statistical tests are obscuring the reality, the individuality of clinical practice. We're all individual. You know, it's a bit like the James Webb thing. We want instruments that bring out our individuality rather than instruments that just give us an orange glow of average effects.
Thank you. That was helpful clarification.
So some of the lessons that you're talking about from the antidepressant experiences are applicable to COVID as well, with a lot of the measures taken to try to mitigate COVID and the COVID vaccines and the controversies over there. I guess I wonder what kind of links you've seen in some of the work that you've done to some of the debates over those issues.
Yeah, well, what I think I'm outlining for you here is standard company practice. And I don't blame companies for that. I'm not in the business of saying, the scurvy knaves in the pharmaceutical industry are responsible for all our problems. If anything, hopefully you've got from the talk, the people who I think have failed us for the last 30 years are doctors. Now, I think in the case of the vaccines and all, you've got exactly the same procedures applying to the trials of them as you have for the SSRIs. This is just the company standard and FDA standard. What results it's delivering are uncertain. I don't think there are any better results than we have with the SSRIs. I don't think they're more informative of good clinical practice than the SSRI things. But I want to say one thing. I'm in the business of looking at the way we do evaluations, rather than, in the case of vaccines in particular, rather than saying, what the right treatment for COVID, etc. is. I've got as much, if not a greater problem with all the people out there who've been advocating ivermectin and things like that, who, if you look at what they advocate, they're advocating putting us on 9 different drugs. And if you think about what I'm saying about polypharmacy being the greatest risk that we've got at the moment, then putting you on 9 different drugs, in addition to the 9 or 10 that you may be on to begin with, isn't, to my mind, a great option.
We're sort of headed towards the end of the hour. Any final questions?
Just a quick point is I'm going to send the text of the talk plus all of the slides to Aaron, and I'm happy for all of you to get all the material and to use it all. I mean, you don't have to credit me with anything. You can use the slides as you see fit.
David, thank you so much for taking the time to talk with us today.
Great. It was good to be asked. And yes, I'm happy to keep in touch with anyone who has any queries and think that there are issues that I haven't fully taken into account.
Thanks a lot.
Okay, take care.
Take care.